Hello guys, it's a wonderful day and I welcome you again to my channel. Once again, as usual, I come your way with a very special electrical wiring that will help you to automatically switch over three different phases or three different supply sources to a single phase load. All right, so this is how it works. Here, assuming you have three different supply sources, say grid, solar, and then genset, and you don't want any power outages to your load. Here, at every time, one of these supply sources will be available to supply power to your loads. This arrangement will help that to be done automatically so that at every time, so far as any of these supply sources is available, you will always have power to your load. Okay, this arrangement also can be applied to a situation where you have three-phase supply all right for your installation. But for instance, in residential installations, most of the appliances we use at home are actually single-phase appliances. And so though you may have three-phase supply available in your house, when any of those phases go off, you still have some of your loads not working. And so, this arrangement can also be done for certain important loads that you will always want supply to get to. And so, in that case, it means that all the three phases will be connected to this three input automatic changeover switch, and then the output will be connected to your loads. So that that load will always get electricity supply except when all the three phases are off. Anytime any of the three phases is available, that load will not be deprived of electricity. All right, so if you are an electrician or you have some background in electrical engineering, this is not a difficult wiring. You just have to pay attention and watch closely. And by the end of this video, you should be able to do this on your own. If you are a beginner or you are an electrical enthusiast, I have some other videos on my channel that are less complex to follow. I recommend that you watch those videos first before coming back to this particular one. Because of the nature of this video, I'm going to draw and explain the wiring diagram of how every connection is going to be done. And again, the wiring diagram is separated into two parts. First, I will do the power circuit diagram and explain it. And then I'll do the control circuit diagram and explain it, just to avoid the whole drawing being too clumsy and to make it easy to understand. All right. And then after that, I will continue with the real practical work. All right, so these are the materials I'm going to use for this wiring. Each of these main switches or circuit breakers will serve as the main switch for each of the three supply sources. So I have this one for supply source 1, this one for supply source 2, this one for supply source 3. Then again, I have three contactors. This will provide us with the three main connections from the three different supplies to the output for the load. And so for the power circuit, we need only these breakers and then the contactors for the power circuit. Then when we come to the control circuit, we'll need to use this auxiliary contact, three of them. One will go on each contactor. This type has two normally closed contacts at the middle and then two normally opened contacts at the extreme ends. So this and this is normally opened. This and this is also normally opened. This and this is normally closed. This and this is normally closed. All right, so two normally closed contacts, two normally opened contacts. And I have one, two, three of them. Okay. The next thing we have for the control circuit is a timer. And for this particular arrangement, we would need two timers for safe and smooth operation of the system. The connection will be done in a way that these contactors will not be allowed to operate at the same time. In a situation where all the supply sources here go off and then they all come on at the same time. When that happens, we have to allow one of these three contactors to operate earlier. And the moment one closes, these two will not be able to work. Okay. And so this wiring is going to be done in such a way that one of these timers will be connected with the contactor that works for the second supply source. And then the other one also will be connected for the contactor that works with the third supply source. Now, this is what is going to happen. In the event or in a situation where all these supply sources go off and then they all come on at the same time, this contactor will operate first. And then this timer will be used to create a time difference for operation between this contactor and then this one. And then this also will be used to further create a time difference for operation between this contactor and this one. So it means that this will operate at a slower time than this, and then this will also operate at a slower time than this. This arrangement should be done in such a way that in the event that the source that is supplying power to the load goes off, the changeover should be done in a very short time, within the twinkle of an eye. Okay, the other thing that is left is the indicator lamps. So I'll also be using these three indicator lamps, and then I'll wire them for each of the supply sources so that at every time we would know whether it is supply source 1 that is supplying power to our load, or it is supply source 2 that is supplying power to our load. In other words, if you are using it on a three-phase system, these lamps will show whether it is line 1 that you are using, or line 2 that you are using, or line 3 that is supplying power to the load. Then this other arrangement here represents the installation in the house. So this lamp and then socket are in our wiring. That will be our load. And so after everything, we'll perfectly see how this changeover works to switch over power to our loads. And this is our consumer unit, and these are the main cables from the ATS that will go to the main switch. Okay, so explanations done. Now let's get to work. All right, so let's get started. Because this wiring is a little bit complex, I'm going to explain a very comprehensive drawing of the whole wiring before I start the wiring itself. Because of the complexity, combining everything on the same drawing will make the whole thing clumsy. And so I'm going to separate the power circuit from the control circuit. The power circuit comprises of the three different supply sources that come into the various circuit breakers to supply power to the load. And so it comprises of the main input cables from the three separate supplies, the output connections from the breakers to the contactors, and then the arrangement at the output of the contactors to the consumer unit. So basically, that is what will be contained in the power circuit. And so I'm going to show the three different sources, that is double pole circuit breakers, then contactors, and then the consumer units. And then the second drawing will comprise of the control circuit. And in the control circuit, I'll be showing the various interconnections between the auxiliary contacts. I'll be showing the connections to the timer. And then I'll also be showing the connections to the indicator lamps. These lamps will tell which of the supplies is available at every time. And then after the drawing, we'll delve into the step-by-step procedure to wire this whole circuit. To make it less difficult, I'll be using this red marker for all my live connections. And then I'll be using this black marker for all the neutral connections. So here we are going to have three breakers. First one here, okay, so these are the three supplies that we are connecting to the automatic changeover switch. And so we have here supply 1, here supply 2, and then here supply 3. Okay, so these are our main switches that control each of the input supplies. The next thing I'm going to show is the contactor. So we have this one, two, three, then four. One, two, three, and then four. Then here also one, two, three, and then four. One, two, three, four. One, two, three, four. And then one, two, three, four. Okay, so this one, two, three are our main switches. So main switch or main breaker. Then here, our contactors. So the contactors are actually represented with the terminals. And so on each contactor, there are one, two, three, and then four terminals for input. And then one, two, three, four terminals for output. The terminals are actually labeled. The labeling is L1 with output T1, L2 with output T2, L3 with output T3. And then another one that is meant for auxiliary contact is labeled 13 and then 14. But in this video, we are going to make use of only two of these terminals out of the four terminals. Now, the labeling L1, T1, L2, T2 does not really matter when using the contactors. All that matters is that one side will take the input and then the other side will take the output. In this video, my L1 is here and then my T1 is here. L2 is here and then T2 is here. Okay, and I have decided to turn the contactors that way to make it convenient for the connections that I'm going to do, especially the connections to the coils on the contactors. Okay, the next connection we are going to do, we are going to link each of these supply sources to their corresponding contactors. So this will be contactor 1 for supply 1, contactor 2 for supply 2, contactor 3 for supply 3. So I said already that I'm using just two terminals out of four. So here, I'll connect live from the output of this main switch to terminal 1, like this. And then I will connect neutral from the output of this main switch to terminal 2, like this. And then the same thing happens to the second contactor. And then the same thing to the first contactor. And so it simply means that we are not using these two other terminals at all in our connections. All these contacts are normally opened. All right. Then now we are left with how to interconnect the output of these three contactors to constantly give us supply output at the consumer unit from any of these supply sources. All right, so this will represent our consumer units. So the main lines that will connect from this arrangement to this consumer unit will have live connected here and then neutral connected here. So at the output side of the contactors, we would have to link the three input supplies and then take it to the consumer unit like this. We take L1 from here to L1 here. It could be T1 depending on how you turn your contactors. But in this particular video, this is L1 for contactor 3, and that connects to L1 for contactor 2. And then we'll take another loop from L1 on contactor 2 here to L1 on contactor 1. So here we'll take a loop to contactor 1. Okay. So in effect, this is the input side of the contactors, and these are the output sides of the contactors. So here, the live output from this contactor is taken to the live output of the next contactor, and then looped to the live output of the other contactor. Okay. And then we do same to the neutral lines. So here, remember we are using L2 for our neutral line. So L2 moves from here to L2 here. And then we take a loop from the same point to L2 here. And then our next connection will be to the consumer unit. Okay. So we take live from here. Okay. So our consumer unit, CU, our contactors, 1, 2, 3 contactors, our main switches or main breakers, 1, 2, 3, and then these cables are coming from our various supplies. So because this is a single phase system, we are using only two lines, that's live and neutral. And so we have live and neutral taken from the output terminals of the main breakers to T1 and T2 as it is in this video, and then the same thing to all the contactors. Then at the output side of the contactors, we had to connect L1 of contactor 3 to L1 of contactor 2 and then to L1 of contactor 1. Then we did the same thing for neutral, L2 from contactor 3 to L2 on contactor 2, and then from L2 on contactor 2 to L2 on contactor 1. Then the same loop is what will feed to our consumer unit. So this is how it works. All these main switches must be closed. They must always be closed. And then, depending on which of these contactors will activate, it automatically sends supply through these lines to the consumer unit. So let's say contactor 1 is activated and then all these contacts closed. They will have live from here flowing through the contacts to the consumer unit. The same thing will happen to neutral. Now, if this is opened and this one is closed, the power that is transferred from here will still go to the consumer unit. And the same thing applies to this third contactor. Now, you can see that the outputs are bridged and all these supplies are not from the same phase. These are three different supply sources. And so it is very disastrous to have all these phases come together. So then it means that one important aspect of this arrangement is that we have to do it in a way that at every time, only one of these contactors should close, because these mains must always be on. In case all of these three supplies are available at the same time, one contactor must be set to operate before the others for smooth operation and for safety. And so how those arrangements are made and how the connections are done will be shown in the control wiring and also in the practical wiring. Because of the nature of this particular wiring and then the time it will take, I will do with the drawing and the wiring of the power circuit in this particular video and do the wiring diagram for the control circuit in another video. All right, so I have already explained the wiring diagram for the power circuit, and so let's move on to do the wiring. So these connections are simply supply inputs from different supply sources. So let's say this one could be a supply coming from the grid. This one could be supply coming from a solar installation. This one could also be supply coming from a genset. As I said earlier during the explanation of the diagram, I'm using terminal 1 and terminal 2 on the contactor. Terminal 1 will be for live, terminal 2 will be for neutral, and that applies to all the others. And then at the output, L1 will be for live output, and then L2 will be for live output. And the same also applies to the other contactors. Okay, so we have first supply source, second supply source, third supply source. All right, so here red goes to T1, and then black goes to T2. Normally with the contactors, it does not really matter where the input and output connect on the terminal. So input can connect to the side labeled T1, T2, T3, or the side labeled L1, L2, L3. What is important is that there must be input at one side and then output at the other side. Okay. All right, so to complete the power circuit, I'm going to use these cables to bridge all the live outputs, and then these ones will bridge all the neutral outputs from the other side of the contactor. So here, live is T1 and then has an output to L1. So this one will come here and then it will bridge with the output of the second contactor. Then again, this one will connect from here to here. Then we also bridge the neutral from here to here. And then from here to here. Then the output to the main switch will connect here and then here. Okay, so output live, bridged, bridged, neutral, bridged, bridged. And then live is taken to consumer unit and then neutral to consumer unit. All right, so if you carefully watch the power diagram, you see that that is exactly what is done here. So now, practically, that is how the power circuit is. All right, so this is how far I will go in this particular video. This is actually part 1. The part 2 will feature both the wiring diagrams of the control circuit and the practical wiring of the control circuit. And hopefully that video should be ready on or before 23rd of June 2024. Thanks very much for watching this video. Please, if you are interested, watch out for the part 2. And if you like what you just watched, kindly click on the like button, share with your friends, and subscribe to stay connected. Thank you very much again. See you in the next video.